So hi, welcome to the first video for the new Yosys HQ YouTube channel. And today I'm really happy to be joined by somebody I'm sure you all know, Olof. So Olof, could you just tell us how we should pronounce your name? Because I know that's been confusing in the past.
Well, I don't have a particular way I want it to be pronounced, but I pronounced myself as Olof.
Olof, okay. And your preferred pronouns?
I would go with he, him, but I'm fine with they, them as well.
Okay, cool. So yeah, I'm really happy to have you here on our first interview with Yosys HQ. You're a real fundamental figure in the open source hardware and EDA tool circles. And these are the kind of people that I'm interested to have on this interview segment. So maybe we can get started with FOSSi. For people that haven't heard about FOSSi, how would you sum it up?
So when I started out with open source silicon in 2010, there was a small hobbyist movement. We had the main site, which was OpenCores.org, was owned by a company. We realized that we had a community that was very highly dependent on a single company for the infrastructure and for everything, like mailing lists and things like that. So we realized we needed a vendor-independent body that could govern open source silicon because we saw it was growing. We didn't know how fast we grow at that point, but we saw that it was growing. So we sat down and created FOSSi Foundation, the Free and Open Source Silicon Foundation. And we had a few high-arching goals. We wanted to provide a place where people could collaborate. And that would be our conferences and LibreCores.org. We wanted to promote and assist open source silicon in the industry, in academia, and for hobbyists alike. And we wanted to have the technical underpinnings as well. So we have, for example, worked a lot of making sure there are licenses, open source licenses that are applicable and usable for open source silicon. So these will be the main things with FOSSi Foundation, center of gravity.
And is ORConf a part of FOSSi?
Yes, so ORConf was originally the Open RISC conference. It was started by Julius Baxter and me before FOSSi Foundation was formed. But it was very natural to move this into FOSSi Foundation as the FOSSi Foundation project. So for ORConf is Open RISC conference originally. It has very little Open RISC content now, and it's the premier place for open source EDA development, IP cores, and everything around open source silicon. It is moving around Europe each year, not last year, but we hope to resume that. It's free of charge, and the intent is to have a low threshold to coming in to open source silicon. So wherever you live, at some point, we hope that we can have an ORConf near you so that so that everyone can attend at least once. And we also started out our sister conference, Latch Up, in the US, because we have a lot of people in the US who can't afford to come to Europe. So we hope to resume that as well.
It is nice to have a hardware conference in Europe, though, I've got to say, as somebody that is normally on the other end of that equation, having to go to the States for the conferences.
Yeah, there's a higher need for that in Europe. I definitely agree to that. I mean, at some point, we hope that we can go into Africa, we can hope go into Asia, but we're doing this totally on a voluntary basis. So it's a matter of resources, how much time and money we can spend from our own pockets.
And you didn't fancy a virtual one this year?
No, so one reason is that we have always had these conferences been about the meetings. We try to downplay the actual presentations and trying to make sure that people are presenting, but more for the purpose of finding new collaborators and finding ways to collaborate with other people. And we think that the whole conference where people meet each other is the main thing there. So instead, we did something very different. We launched a series of seminars with high-profile speakers, one each month, called the Dial-Up instead of Latch Up. So that's what we did instead.
Okay, the FOSSi. So, yeah, actually, I knew about FOSSi Dial-Up, but I didn't realize it had come out of that. So that's good. talking of open source silicon, because all of those dial-ups were the first one from Tim Ansell was about the announcement of the open PDK from Skywater, and then we had subsequent ones from eFabless with Mohammed, and then an open lane one again with another Mohammed, and then we had Memory Compiler with Matthew, and who else? We had Tim Edwards talked about DRC with Magic, I'm sure, and then there was another one about standard cells, I think. But that was really the beginning of a bit of a revolution, I think.
It definitely was. So this project is a great project. We've been waiting for this for a long time. There have been bits and pieces lying around, but just this whole end-to-end flow, it's amazing. And I think one thing that Mohammed Kasim said, that 75% of the participants in the first shuttle were software engineers, or they defined themselves as software engineers. And these are people who would never have done an ASIC if it wasn't for this. And now we suddenly have at least 30 new people who have taped out an ASIC. And I think that is amazing. This is just the beginning of something.
Yeah, I mean, I wouldn't count myself as a software engineer. I'm more of a hardware, but I didn't think that I would ever get the opportunity to tape out an ASIC either. So I was really excited to be involved in that.
Yeah, right. I totally. And I would have done it myself if I had the time. I hope to catch one of the coming shuttles. Yeah,
I'm sure. Let's move on to LibreCores, given that we're talking about, I mean, one of the things about so the Open PDK is very exciting because that opens the doors to sharing all the way down to the GDS. But part of the free Google shuttle, the sponsored shuttle, which is very exciting from my point of view in terms of actually getting silicon in my hand, is that the designs have to be open source as well. And that kind of fits in with LibreCores to some extent, doesn't it?
Yes, very much so. So right now we're not fully there yet. The idea is to have a community hub with LibreCores where you can share designs, share IDs, share knowledge. We did not want to go down the route of OpenCores. So LibreCores is not a clone of OpenCores. We don't do hosting. We try to be more of a, since much of the development is on different GitLab servers, on GitHub and other places, we try to be more like a curated list of IP cores and tools where you can more easily find these things. And then we are looking towards also FUSOC integration. So it would be more like a PyPy if you're a Python programmer, or Rust has something similar.
It's like a package installer, isn't it, for Python?
Yeah, exactly. So people, the idea is that people should be able to upload and register the course on LibreCores with a pointer to their repository, and FUSOC, the package manager, would then be able to find these things just so you can quickly share designs with other people in a way that is not yet possible.
Okay, so what would you say the biggest difference between LibreCores and what was the other one you mentioned?
OpenCores.
OpenCores.
So OpenCores was extremely important. It was created in 1999, which we say is the year zero of open source silicon. It was where RISC was started and a lot of IP cores, but it wasn't a good tool for collaboration. All these IP cores has very much lived in isolation. Any project that kind of reused them, they used it in a way where source code was just copied into a larger repository, and then you had to form a bigger design. And this was the problem that I saw quite early on, and which is big motivation why I started FUSOC, to make it easier to reuse IP cores. But we also, and FUSOC already supports reusing IP cores from OpenCores, from GitHub, from other places. But I think the next step would be also to empower users to more easily share designs.
Yeah, it seems like a lot of the projects that you put your effort into is about community building as well as the technology. Can you say a couple words about that?
Yeah, so I think there are so many great projects, and I always said that I think I'm a pretty good programmer because I don't really like to program all that much. So I try to use what's available. And the problem today isn't that we lack good IP cores or technologies. It's that we lack the means to put them together and make them accessible, commoditize them, all these things. And so this is very much what some of my projects are about. Like I have like Fusoc, for example, package manager, tries to make it easy to build designs from other people's cores. Idealize is the way to abstract away the EDA tools themselves, so you can more easily switch between tools, so you don't necessarily are locked into a tool. I have a small project called Led to Believe, which is just about making a Blinky on every FPGA board in the world. So it's just a fun exercise for people to get started and do something where they can actually see something happen and they can contribute. I think that's prototype things like that as well.
Yosys HQ, open source EDA tools and related software development. So talking of one specific IP core in particular, on Twitter I've been led to believe that you've won a few awards in your history, and one of them is for something called SERV.
Oh, right, yeah, that's a familiar name. So it's SERV is the world's smallest RISC V processor. And it won an award.
So there was a competition like a year or two ago, wasn't there, for new RISC V cores? And
yeah, so
you won the creativity prize on that or something, I recall.
Right. So the history around that is that at ORConf in 2018, there was an announcement made that there will be a RISC V soft CPU contest where people had to create the smallest or fastest RISC V core under some criteria. It should run a SERV operating system. It had some constraints. And there were 2 months, I think, till the deadline. And I sat there in the audience thinking, oh, this sounds like a lot of fun, but I have absolutely no time to start another project. So I just went home. So a month after ORConf, I was doing the dishes and I started thinking about, I wonder if you could do a bit serial core. I didn't know that was a thing really, but I kind of figured maybe you can do just one bit at a time. So I started scribbling down some stuff on paper. And then...
So just to interrupt there, so normally with a CPU, you're processing like a word at a time, and a word is made like 32 or 64 bits or whatever.
Yes.
And a bit serial core is, you might still have like a 32-bit register, but you only work on 1 bit at a time. Is that correct?
That is correct. So you trade area for time. So you can, in many cases, you instead of having 32 gates of some kind, you have 1 gate and you reuse it 32 times. So it's 32 times slower, but uses
32 times smaller.
Yes, exactly. So I started scribbling down some notes on paper, and then thought, yeah, I should just open the computer and run the simulation and see how that would be. And then I kind of just began. So over evenings and weekends for a month, I started working on this CPU, and it was never meant to be a CPU, but it became a CPU eventually. So about 3 hours before the deadline, I actually finished the last thing and submitted it, and kind of assumed it wouldn't get anywhere until I was notified that I had won the creativity award at the RISC V Summit. I wasn't there. I just saw people started telling me about it.
Yeah,
it was a lot of fun.
And that's kind of led on to a couple of other things. So you've kind of been playing lookup table golf, LUT golf, and trying to shave lookup tables off in the FPGA implementation of SERV. But you've also got something called Core Score now.
Yeah, so it's kind of, I had the world's smallest CPU. When I should also say that when I won the creativity award, it wasn't that small. So I started really working on making smaller after that. But then I started thinking, what could I do with this thing? So first I actually started doing a heterogeneous sensor aggregation platform. Very fancy word for the idea was that you should, if you have a lot of sensors connected to an FPGA, you should be able to communicate with all the sensors using a combination of software and hardware. So you can like do stuff like high-level sensor communication in software, but maybe do some FFT or do some post-processing and custom protocol implementation in hardware. And since SERV was so small, you could attach one CPU to each of these sensors and have very good real-time capabilities. The problem then was that I quickly ran out of sensors, so I didn't have so much to test this with. So I had like 2 sensors, and then I had room for 30 cores in one FPGA. So then I started thinking instead, fuck it, I just see how many I can fit into the FPGA, and just having them print out a message each. And then I created something called SERV Mark. And 3 minutes later, I thought that CoreScore was a better name. I did release a better name.
And then we've got a character too now called Corey.
Yes. So Corey is actually Corey is older. Corey was done before that. So Corey is the FUSOC mascot, really.
Okay.
But she makes an appearance in CoreScore. So that's probably where people know her from now.
And what's the largest number of who's on the high table? Can you remember?
Yeah,
I'll load up a graphic.
I do know that the first place is 5,087 SERV cores on a high-end Xilinx device, followed by 3,040 cores on another Xilinx device, and that the second one is a bit fun because that is a HAPS, which is like this big Synopsys ASIC simulation platform that the guy bought secondhand, much cheaper than they are new, and figure out how they worked and put all these cores in it. So it's for cores per dollar. It's really it's good bang for the bucks.
Do you have that as a column in CoreScore, cores per dollar?
I have been thinking about it, but it's too much hassle keeping it up. Also, we have one guy who had this Cisco modem he bought for like $8 or something on eBay, and could fit like 70 cores into that. So they're all sorts, and I think it does serve 2 very real purposes. It's a way to get a better understanding of how big your FPGAs are, because when people talk about LUTs, there can be different LUT sizes, and it can be very hard to know, especially coming into the field, how large your FPGA is and what you can do with it. Just having one number that tells you that this one is 10 times bigger than the other one, that probably helps a bit. And also, it's a lot of fun. I think people are having fun trying to push as many cores as possible.
I'd say most of the in-jokes on Twitter are based on SERV or CoreScore.
Yeah.
One person wants to know if you're actually 100 RISC V cores in a trench coat.
I won't go into detail on that.
And someone else wants to know if you took all your FPGA dev boards and you filled them all with SERV cores, how many would you have altogether? You probably don't know that off by heart.
No, I don't know. Actually, I don't own that many big boards, but I'm trying. So there has been this prediction that there will be 62.5 billion RISC V cores in 2025. I'm just trying to do my part.
Okay, yeah, that's good. We all need to play our part. Just while I'm on Twitter, I think this is maybe an in-joke that I'm not aware of, but someone's asking, when will documentation week be?
Yeah, so at some point I tried to... I have been apologizing a lot for documentation, lack of documentation, and
okay, right.
I think that I've said also that if I would have spent as much time writing documentation as I've done apologizing for the lack of documentation, the documentation would be really, really good by now.
Yeah.
So I'm sorry about that, and I need to fix it. But one thing that happened this year was for FUSOC. So fellow FOSSi Foundation director Philip Wagner did a huge job in making the FUSOC documentations very good. So I'm super happy about that. And for SERV, I actually tried also to make some documentation. I tried to do block diagrams of where I write down each and every...
Yeah, they were really good actually. The quality of those diagrams was great, but I really felt your pain a little while later when you said you shouldn't have made the documentation, because now it takes 3 times longer to update your documentation every time you make an improvement to the core.
Yeah, so I need to stop making improvements to the core now.
That's one way to call the end of that game. So here's a really general, broad question, but I think you're really well placed to answer it. How do you think open source is shaping the EDA world, and like, what are your predictions for the kind of coming years? You know, we've got these open source RTL to GDS tool now in OpenLane. We've got lots and lots of open source ASICs coming off the end of this shuttle. We've got more and more people doing open source EDA tools. RISC V, as you say, is an open ISA. What do you think is going to happen in the future, and how is open source important to this?
So I spent a lot of time thinking about this. So hopefully I can answer some of that with some confidence. So when it comes to open source EDA tools, they will be playing a bigger part. The question is how, and I think we need to look at how they differ from the proprietary tooling. And two things that stand out is cost and innovation. So the cost, these open source EDA tools have a lower cost in two ways. They have a lower upfront cost, a purchasing cost.
In terms of like not having to pay license fees or whatever?
Yeah. Not all of them, but and also, I mean, many of the FPGA vendors, for example, provide some kind of no-cost version, a limited no-cost version. And for many companies, this really isn't the problem. For some it is, for some it isn't. But then we have the cost of usage, and I think that is a cost that's not as much talked about. It's the cost that when you need to, there are two aspects to this. One is the cost of just having to deal with licenses, like you wasting engineering time for people who can't use the tools because license server is down or they're waiting for someone else to be done, and all these small hiccups. I think engineering time is probably pretty expensive. I think it can easily come up to the levels of the actual tool costs just in lost engineering time. And there are another things, like I have been working I started working in the industry for what at the time was the largest FPGA buyer in the world. When we had problems, they sent down to FAEs to help us out directly, and they internally called up their internal people and provide us with internal builds and things like that and fix the problem. This is not what it is like in most companies. Most companies, you are sent to some support, and it can take weeks and months, and this is lost time, this is lost money, it costs so much, and in many cases it's very simple problems in the EDA tools, but as you don't have any means to fix them yourself, you just get stuck. And as opposite to this, I was working with the QuickLogic. So QuickLogic has released the world's first open source vendor approved toolchain, FPGA toolchain. And I had a problem with that. It was a parameter that was badly tuned, so I needed to. So the design didn't instantiate in the way that I was expecting it to do. I started chatting with the people, and in 15 minutes they had given me the file which I should change, and I could fix it. And I had lost like half an hour, and I could continue working. And this is in a big company, this would be a huge difference in costs. Just having your engineering department not be able to work for weeks because of bugs like this. So this is a cost this is an area where open source tools can provide a much larger cost reduction, I think. And then it's about innovation. Sometimes I can wake up in the middle of the night and just come up with a song ID, do some recording, and then I can just turn on the phone and start singing into the phone because I have the means to do it. Or if I have an ID for SERV, I can just start up the computer and start simulating or synthesizing anything just at home anytime I want. But if I need to have a license, if I need to be at the office, if I need to clear with management that I need this license, I need to sit with this at this workstation, this opportunity of innovation will be lost. And I think we're losing so much innovation with the proprietary tools that they are.
People come up with an idea in the shower.
Yeah, exactly. And then they kind of forget about it before they have a chance to do it properly. But if you give them the means to do it quickly, I think. And for me, was with formal verification. I did some formal verification at school, and then I started work, and I asked, "Hey, which formal verification tools are you using?" And they said, "No one is using formal verification." And since there were no open source tools or no free tools, I couldn't do formal verifications, and I kind of just lost the interest in it until Claire presented at ORConf 2015, presented the Symbiosis tools, and I was, wow. So suddenly I can do formal verification again, which I haven't been able to do. And this is also something that it costs for the companies, because if they want to hire people who know formal verification, they have a much smaller pool to choose from if these tools aren't available. Mm-hmm. So this is good for the chip industry in general. It will allow more people to go into it. It will allow more developers to test out new ideas. Another thing, we have the GHDL simulator, which is a VHDL simulator. And quite recently, it has been used not only as a simulator, but as a front end to get VHDL support for Yosys. I don't know if you've heard about Yosys.
Just remind me again.
Yeah,
what does it do?
It's this amazing synthesis tool. It's a company formed around it.
I a couple of weeks ago, I interviewed Anton Blanchard about a CPU core that he'd put on the eFabless Google Skywater shuttle, and that was written in VHDL, and they were using GHDL for the simulation. Yeah, right. So yeah, that's a perfect example of that, because this. So yes, there are probably proprietary tools where you can take a VHDL description and at the end get out like export a very long let list or something like that. But just taking a tool and using a part of it and reusing it in another context, that is very much what open source allows. For my own project, I split out Edelweiss as a part of, it was originally part of FUSOC, and I split out to its own library because I thought it would make sense on its own. And people are using Edelweiss now without using FUSOC, so you can take bits and pieces and combine them in new ways. And all this, I think there's a lot of research going on place and route, for example, and synthesis, and they can now base this on Yosys or NextPNR or VPR instead of having to create a tool from scratch for the research. So there's so much innovation we are unlocking with open source EDA. But I don't think that was where it will start. I think it will start with the tools that bridge between the open source and the proprietary EDA tools. So one project I think is going to become important is Cocotb. It's a testing framework where you write your testing code in Python, but it uses the traditional simulator flows. It can use open source tools like Verilator, or it can use proprietary tools like Cadence tools or Mentor tools. And I think it will start like this because the companies will find that they can now hire Python developers instead of System Verilog developers to write the verification code, and there will probably 1,000 Python developers for every System Verilog developer. So it is a matter of economy. It doesn't harm the EDA tool vendors because you can still use it with your old Cadence or Synopsys flows. And the same thing for the developers who are using these things. If they are used to using a certain simulator, they can still do that. But I think we will see them switching over in time to more and more open source tools. That's your golden prediction for the next 5 years.
Yeah, I'm usually. No, I'm not right. I'm usually wrong. what I could write.
Okay, so just as a final thing, I wanted to informally present you an award for being our best interviewee.
Yes.
So you can add that to your list of accolades.
That's perfect.
And thanks very much for your time and for coming on our new channel.
Well, thank you for having me. I had a great time. I'm looking forward to see more.
Great, fantastic. Thanks, Olof.
Take care. Bye.